Do you ever look at your grandma and think, how old is all that? Well, carbon dating is your way to an answer. It is determining the age of an organic matter from the relative proportions of carbon isotopes.
Cool!
Basically, carbon dating is determining the age of a fossil by counting how much carbon-14 is left in the fossil. Carbon-14 is the most important isotope or type of carbon particle because it is what is used to measure within carbon dating. With that, carbon dating is significant in the field of archaeology because it finds near the exact age of a fossil. Another important part of carbon dating is half-life. Carbon-14 has a half-life of 5,730 years. But what is half-life? Half-life is the time required for half of the atoms in a substance to decay. There are two different processes in which atoms decay.
The first is alpha decay. Alpha decay is release of an alpha particle or two neutrons and two protons from a particle's nucleus. As a result of this, the identity is changed, and you can see this uranium-235 mutates into thorium and helium. The second is beta decay, and beta decay is the release of a beta particle or an electron from the nucleus. But how does an electron leave the nucleus, you ask? Well, a neutron, which is present in the nucleus, often splits into an electron and a proton, and they are released from the nucleus. This also changes the identity of a particle. As you can see here, this carbon-14 matures into a nitrogen, an antineutrino, and an electron.
Some pros of carbon dating are, it can find the precise age of a fossil given that none of the atoms were lost. A con is that the atoms are usually found in igneous rocks, but most fossils are not usually found there, so it isn't reliable in that aspect. Another pro is that it can create a concise counter for up to 50,000 years ago.